now presenting my second example of setting up a linear program. So let's see, we have a farmer who has 70 acres of land available. He's planting soybeans or wheat. And lots of information in the table at the right. We've got preparation costs per acre of each of these soybeans and wheat, the work days required per acre, and the profit per acre. So let's look back to the left again. The farmer has a limitation, limited to 120 work days and $1,800 in preparation costs. So how many acres of each crop should be planted to maximize the profit? Well, again, our linear program always has three ingredients. The first would be the variables. Now, what should our variables be? Well, the last sentence says how many acres of each crop should be planted. We only have two crops, soybeans and wheat, so we will have a two-variable problem. So we have the number of acres of planted in soybeans, a number of acres planted in wheat. Let's just abbreviate that by using S for soybeans, and then W for wheat. And keep in mind that the unit we're talking about here is acres. Soybeans and wheat. Now our objective function here, it's what we want to maximize or minimize, and this problem is a maximization. We want to go and maximize the profit. Okay, so let me make this a little bit larger. It might help if you have a small screen. There we go. Now, what I just typed, our profit, that is the objective function. It's the object of the problem to maximize profit. So let's convert that into an algebraic statement. Now, if you started with example number 1, you know that this profit function can contain possibly both of our variables, soybeans and wheat. Now, will it contain them? It depends. We want to see if there's a profit associated with both soybeans and wheat. So we'll look over here at the table and we see, yes, a soybean an acre gives us a profit 180, so that is the coefficient of S. And then wheat has a profit of 100 per acre, so that coefficient would be 100. And to get the total profit statement, we just want to add the profit on each of these different crops. So there we go, we got our objective function. Now we have constraints. And as I described in the first video, constraints are either limitations or requirements. So we have to search for those. Now we would seem to have a limitation here in terms of 120 work days, and then a limitation in terms of how much money we have for prep costs. So let's just come down here and let's label each of those. Okay, so work days, and then prep costs. And let's create a statement for each of those. Now, just like the profit statement, you figure you'll probably have an S and you'll probably have a W. To determine if you do, you want to see if there's a number of work days associated with each of those. And of course, in the real world, the answer is, of course there would be. Now, what are they? Well, over here in the table, we see there are 3 days for soybeans and 4 days for wheat. So those would be our coefficients there. So the total work days then would be obtained by adding these two together. Now a constraint, the difference between a constraint and the objective function is you'll also have another side to this problem. Our work days, what are we limited by? 120, limited to 120 work days. So that means we have to stay within 120. That would be represented by less than or equal to 120. Very important thing if you're a beginner, and hey, you probably are, or you wouldn't be watching this, make sure that the 3, the 4, and the 120 are all talking about work days. You don't want to get any numbers associated with prep costs in this statement. The numbers associated with prep costs will go in this next statement. So prep costs. Well, again, look for S&W. What are the prep costs for those? Well, prep costs are 60 and 40. So we would have 60 applied to soybeans, and then we would have a plus sign. We would have 30 applied to wheat. Now, for prep costs, what's our limitation? We see it's 1,800. So we would have less than or equal to 1,800. Okay, so we're doing pretty good here. We've used all of these numbers. It might appear that we've used everything. Now, as beginners, I recommend always look back and see if there's anything you may have overlooked. And look at that very first sentence. A farmer has 70 acres of land available. So that's a limitation also, isn't it? We are limited in terms of our land. So let's see if we can come up with a constraint for land. Now, what sometimes confuses people is they go, well, gee, for work days and prep costs, it was easy to find coefficients, but what coefficients would you have for land? And the problem is you're making this one more difficult than it has to be. We're planning S&W, right? We're planting soybeans and wheat. So and we're talking about acres when we use those variables. So all this really is our soybeans, our acres of soybeans plus our acres of wheat need to be within 70 acres. In other words, the coefficients are just ones. Now, I will point out that if you go to solve this using Solver, again, you can refer to my Solver video, you would want to perhaps make explicit the fact that the coefficients here were 1. So as far as I'm concerned, I'm okay with my students putting the ones in there. And for all I know, you might have a teacher who's kind of fussy about that and doesn't want you to. But it's at least important to realize that there are implied ones there. Okay, now we can easily get the answer to this with the Solver video. I guess I should point out one more thing for the sake of completeness. You cannot plant a negative number of acres, so it is also the case that S and W need to be at least 0, greater than or equal to 0. Okay, I will sign out here.